Hi, everybody. This is Mike from the University of Hong Kong. Today I'm going to talk about new platform that we developed for the public housing projects. It's called eTranstar 2.0, a blockchain and AIoT-enabled smart logistic platform for just-in-time delivery of prefabricated modules. The reason that I call it eTranstar 2.0 is because previously we have developed a logistic platform for the modular integrated construction. But that platform only tracks the real-time location of these MSA trucks. But right now we integrated the blockchain technology and AIoT into the platform. So some of the new functions. As you know, Hong Kong is using a lot of modular integrated construction techniques for different types of projects, such as student housing projects, transitional housing, elderly homes, and quarantine centers. All these projects are actually adopting modular integrated construction here in Hong Kong. So traditionally, we design these MSA projects in Hong Kong, and because of the high construction cost here in Hong Kong and the aging problem, lack of shortage of the labor forces, all these challenges putting together makes us to have to outsource the modular housing production to the Great Bay Area in mainland China. So almost 100% of these MSA projects are actually manufactured in the Great Bay Area in mainland China, such as Zhuhai, Foshan, or in Shenzhen. So, and after that, they have to do the cross-border transportation and to install all these MSA modules here in Hong Kong finally. So the cross-border transportation here is very, very important. That's kind of like the point of departure for our proposed research. And I have taken some of the photos from the construction site here in Hong Kong. It's actually one of our student residential projects. As you can see from the photos here, the construction site here in Hong Kong is very, very congested. So if you look at the photos very carefully, you will be able to tell like there's only one parking space here for MSA logistic drivers. So it's a big challenge for Hong Kong to achieve just-in-time deliveries. That's why also the just-in-time delivery here in Hong Kong is very important. So because of this problem, Professor Lu and I, we applied research funding to achieve just-in-time delivery MSA transportation planning. So our proposed platform has three major functions. The first component is that we want to develop a estimated time of arrival model for MSAs. And then for the second component, we want to achieve dynamic and resilient MSA modules just-in-time delivery. And finally, we want to use blockchain technology to record these driver behaviors so that we will be able to do some of the performance review after completing of these projects. So we conducted a pilot study in Hong Kong together with the Housing Authority on a public housing project. So all the modules are actually manufactured in Zhuhai, a city in Guangdong province in the Great Bay Area. And then all these modules will be delivered from Zhuhai via the Hong Kong-Zhuhai Marco Bridge and finally comes to the Anderson Road quarry site here in Hong Kong. So first thing first, if you look at your Baidu map or Apple map, there is no function tell you what is the estimated time of arrival for MSA trucks. It only tells you, if you look at the screen here, it only tells you the ETA for buses, for taxis, for subways, or for private cars. It doesn't tell you the estimated time of arrival for MSA trucks. So I have to go to the construction site or all the MSA factories in Zhuhai to attach this AIoT sensors to the prefabricated modules, so that we'll be able to collect lots of MSA delivery data to build up this ETA model for MSA. So this is actually our proposed platform user interface. So because of this collection of this big data for estimated time of arrival, we will be able to do a more accurate cross-border logistic planning. So if you look at the interface on the right-hand side, after you inputting the departure location and the destination, the system will automatically tell you how long it takes to get to the destination for MSA trucks. And based on the first component, the ETA function, and then we integrated AI smart algorithms into the platform. So in this case, we'll be able to close monitor the real speed and locations of these MSA trucks by using our AIoT and together with the smart algorithms. And then we can send all these instructions to drivers to tell them to dynamically adjust their delivery speed. For example, when previous cars has still on the construction site, the system will automatically tell the following truck drivers to slow down their speed. So the system will also consider the real-time road conditions, the ETA, and also the interim parking ports, and other conditions such as weather conditions. So the AI algorithm can actually inform all these MSA truck drivers to adjust their speed. So this is our user interface for the just-in-time delivery. As another example of if the MSA truck drivers are late for departure, so the system will also automatically send messages to following truck drivers to delay their departure from the MSA factories. So for the MSA truck drivers, they can just simply use the mobile apps. So the system will send the voice message and as well as a text message to the MSA truck drivers. So they will be able to adjust their speed to achieve just-in-time delivery. So the system will, if you look at the picture in the middle, the system will also automatically identify the arrival of the MSA trucks at the construction site. So whenever there is the MSA truck driver at the construction site, the system will send a warning message to the following MSA truck drivers. The system will also suggest the buffer zone or to ask the following MSA truck drivers to slow down a little bit to achieve just-in-time delivery. So we use the blockchain technology to record all the truck driver behaviors that allows us to further analyze their behaviors, because we didn't achieve 100% just-in-time delivery because some of the drivers failed to follow the instructions of the systems. So because of the use of the blockchain technologies, so we will be able to do some of the performance review in the later stage. So what's next? In the next following months, we will be able to integrate another AI component into the platform. So what we're going to do is we're trying to use this AI model to learn some of the critical points with high vibrations. So the system will also automatically send a reminding message to the drivers when the vibration is high. So when next time the drivers come to these critical points, they will receive a proactive message to slow down their driving speed in order to avoid the damage of the MSA modules. And that's the end of my presentation. And thank you for listening.